So this is problem 44, chapter 5 of Halliday, 9th edition. So let me mark here, chapter 5, problem 34, Halliday, Halliday's book, 9th edition. All right, so let's have a look and read this problem. So what we have is, again, an elevator. It's as common in this kind of problems. Get this out of our way. So we have an elevator, and from inside this elevator, we have a lamp that is hanging vertically from a cord, and this elevator is going down. And well, let's start by making drawings, and then we continue reading. We have here our elevator. From here we have a cord, and from it we have a lamp hanging. All right. This elevator is descending, so the velocity of this elevator is pointing down. But careful with what they say. They say that this elevator is decelerating, and so it's slowing down. So the acceleration is opposite to the velocity. That's how we slow down, when the acceleration is opposite to our velocity. Okay, so this is an important piece of information. They tell us what is the magnitude of this acceleration, 2.4 meters per second squared. They also tell us the tension in the cord. Okay, so I'm going to mark here, there is tension here in this cord holding this lamp so it doesn't fall. And the magnitude of this tension is 89 newtons. Very well. And then comes this question for part A of the problem. The question is, what is the mass? Okay, so they didn't give us the mass of the lamp. So what is the mass? We have enough information to find the mass. How? Well, we have to remember, of course, that there is the weight of this lamp. We have mg pointing down. And well, we go for the equation. Now, the sum of all the forces in the y direction, these are the only two forces that we have, equals to ma, which a, the acceleration that we have in the y direction. To do that, now we have to choose a frame. I'm going to choose a frame which is pointing up. So whatever I have, whatever I see, any vector that points up will have a positive sign according to that frame. Very well. So now let's go put the forces in that equation. Tension force is pointing up, just like our frame. So tension force is positive. The mg, no, the weight of the object is pointing down opposite to the frame. So we have here minus mg. That's what we have on the left side. These are the forces. And on the right, the sum of all the forces will give us the mass that we are after, and the acceleration. Now, the acceleration is also pointing up, right? The acceleration is against the velocity. The elevator is going down, but the acceleration is against, so the acceleration is pointing up. Up in our frame is positive. So here we have plus a. That's it. We have everything now that we need to find the mass. And so I'm going to rewrite this equation like this. I'm going to put the mg on the other side, it becomes positive. So mass g plus a. And here now you can get this mass is the value of the tension force divided by g plus a. Everything here now are numbers. We already took into account the directions. Now, so ft is just 89. G is just 9.8. We already took the sign into account when I wrote it here. A is 2.4. And from here, you can get to the mass. The mass is something like 7.3, if I remember correctly. Okay. Now comes the next part of this problem. We already, so we found this mass. And the second part of this problem now is, well, let's change a little bit this problem. What is it that is changing now? They say, the question is, what is the tension? Now they ask about the tension on this cord. If instead of going down, this elevator is going up. Now it's ascending. Okay, so what is going to change? The velocity now is going to be pointing up. It's ascending. But look, it's Ascending is going up with an upward acceleration. So nothing has changed about the direction of the acceleration. This elevator now is speeding up, is going up with the same acceleration. So everything that we did in part A holds also for part B. What do we need when solving these problems? We need the acceleration. Well, it's the same as we had in this other problem. What do we need? We need the mass, which we already found. The two forces that are involved in this problem is still the same direction. Now, if you want, we can go on and rewrite the story. Now, so, but we have here the lamp, mg pointing down, just as above, tension force along the cord pointing up. So you see that we have exactly the same thing as before. Tension up, mg down, acceleration up. Why is up here? Well, because in this problem, the elevator is moving down, but this elevator is slowing down. No, the speed is decreasing, is decelerating. The acceleration is opposite to the velocity. In this other scenario, well, the elevator is going up, but it's speeding up. So the acceleration goes together with it. And so at the end, you have the same scenario. What matters in this problem is not if the elevator is going up or down. It's not the direction of the velocity. What matters is the direction of the acceleration. The acceleration, the direction of the acceleration that you put on the right side will determine the solution. So the problem is going to be exactly the same, and you're going to get what, for the tension, the same number, 89 newtons. And that's the end of this problem.